So now we're doing question 15 on section 3.2, and we have to find the derivative of this function right here, so we have to use the definition of a derivative. So let's look at some components. We know we have to replace well, I'll write it down. So s prime of t equals the limit as h goes to 0 of t plus h cubed minus t plus h squared. So we took care of this part. Now minus s of t. Well, s of t is t cubed minus t squared. So minus a t cubed is a minus t cubed. Minus a minus t squared is a plus t squared. And that's all over h. Now, let's look at the components. T plus h cubed. If we let's see, if we have a t plus h and you cube it, if you know Pascal's triangle, you know how to do it very quickly. Otherwise, you have to FOIL it out. And what you're going to get is t cubed plus 3t squared h plus 3th squared plus h cubed. And you also know that t plus h squared, when you FOIL that out, you get t squared plus 2ht plus h squared. Now, let's install these values, these identities in for t plus h cubed and t plus h squared. So now s prime of t equals the limit as h goes to 0 of, and for t plus h, that quantity cubed, we've gotten, by the way, we made a nice long bar here, and h, and I'll put t cubed plus 3t squared h plus 3th squared plus h cubed, and minus t plus h quantity squared. So that's going to be minus t squared minus 2ht minus h squared. And also we need these components, this minus t cubed and plus t squared. And now the t squareds are going to add out, the t cubes are going to add out, and all the other terms in the numerator have a factor of h in them, so we'll factor that factor of h out. So we'll factor an h out of this term, and we have 3t squared. We'll factor an h out of this term, and we'll have a 3th. We'll factor an h out of that term, and we'll have plus h squared. We'll factor h out of this term, and we'll have a minus 2t, and factor an h out of that, we'll have a minus h. Now, division by 0 is eliminated because the h's divide out. And now when we let h go to 0, notice this is going to go to 0, this is going to go to 0, this is going to go to 0, and we're just left with 3t squared minus 2t, because h went to 0, so those terms became 0. Now, we need to know, our task was to determine what the derivative was at t equals -1. So we'll look at s prime of -1, which equals 3 times negative 1 squared. Well, negative 1 squared is 1, and 3 times 1 is 3. Negative 2 times negative 1, because we install negative 1 in for t, is going to be a plus 2, and that equals 5. And we've got it. So now we're doing question 19. We have to find the value of the derivative at t equals negative 1. This is just another form of notation, means the very same thing. Just find the value of the derivative for t equals negative 1. Well, there's our s of t. Now we have to find s of t plus h. And that's going to equal 1 minus 3 times t plus h squared, but you already know that's going to be 1 minus 3 times t squared plus 2ht plus h squared. And so now ds dt at t equals 1 equals the limit as h goes to 0 of this thing, and I'm going to multiply through by that negative 3, and made a big division bar there, h, and I'm going to get 1 minus 3t squared minus 6ht minus 3h squared, and now we're going to subtract s of t, so 1 times the negative is going to be negative 1, and a negative 3t squared is going to be a positive 3t squared, and we're going to evaluate that for t equals negative 1. So now you notice that the 1's add out, the 3t squareds add out, so we've got the limit as h goes to 0. And now the only two remaining terms in the numerator, we can factor a t out of each of those, or an h out of each of those, I beg your pardon, h, times negative 6t minus 3h all over h, and we're going to evaluate for t equals negative 1. So those divide out, and this equals now letting h go to 0. We're going to let h go to 0. This term, we lose this and we get negative 6, and we're replacing t with negative 1, and so that equals 6, and we are done. We did it.